Example 14. A rigid crank arm is loaded and supported as shown in the figure. Determine the components of the reaction at support A and the force exerted on the arm by the link at C. So we will draw our free body diagram here. So if you can observe, since at A, this is pin connected, so therefore we have, let us assume that the y component is going up, and then the x component is also going to the right. Now for letter G here, although this is also pin connected, but if we can observe, let us say if you have a force applied here at E and E, so in other words, sabi ni siya, pag gibira siya no, gibira pa, hindi gibira tuda na. If either gibira or gitulod, the only force being exerted here is kanira nga, is only a force to support this pin here. Meaning if this is our solid concrete here, then nakaka-link, and then mo ni ang ato ang G, right? It only supports one force, the horizontal only, no vertical. Kay dili man ni siya musaka pataas, only it's either matduot pa siya paingon dito or birahon siya paingon dito. Okay, so therefore we'll have three unknowns. G, horizontal. It can be going to the right or going to the left. Oh wait, C here. So sorry, that is not G but rather C. So it's either C sub X going to the left or C sub X going to the right. Okay. Now knowing that, let us create our free body diagram. Okay, going down and then a bar here. Now at A, this is A. We have soon going up A sub Y, and then to the right A sub X, and then let us say at point C to the right as well, right? And at B, which is 3 feet from 3 feet from our A and 2 feet from C, we have a force applied here, horizontal, and that is 300 pounds. And then at point E, which is 4 feet from A, we have 600 pounds going down to the right with an angle of 60 degrees. The magnitude is 600 pounds. And at point D, we have a couple here, which is 750 pound-feet. Okay. And let us provide the dimensions. Wait, but before we provide the dimensions, let us place some letters here. This is C, this is B, this is A, this is D here, and then E. Okay, now the dimensions from A to B, that this is 3 feet, and then from B to C, this is 2 feet. Okay, from A to D, that is 2 feet, and D to E is also 2 feet. 2 feet, 2 feet. Okay, so just like last time, if we are to do some force summation in either X or Y, uh, we uh, will have two unknowns for our X, and that is C sub X and A sub X. However, for our A sub Y, since only A sub Y has a Y component, then we can do force summation in the Y. So let us do that. But before we do that, ito lang ko sa express si E in terms of its x and y components. So we have E sub y, and to the right is E sub x. Okay, so we have summation of forces y is equal to 0, assuming upward positive, and that is A sub y minus E sub y is equal to 0. So A sub y is equal to E sub y, and E sub y is equal to 600. And the y component, since our angle is measured from the horizontal or from the x, so therefore 6, that is 600 sine 60 degrees. So our A sub y is equal to 600 sine 60, and that is 519.615243 pounds. And since we ended up with a positive answer, so therefore our assumption is correct that A sub y is indeed going up. Okay, next. Like I said, if we do force summation in the x, we'll have two answers. So therefore, since we have used already one equilibrium equation, which is summation of forces y, and we cannot use summation of forces x, then we move on to summation of summation of moment. Now we can have moment at C, or we can have moment at A. If we do moment at A, we can get C sub x. If we do moment at A, we can get A sub x. So let us have moment at A for this example. So summation of moment at C is equal to 0. At A, sorry. At A is equal to 0, assuming counterclockwise positive. Counterclockwise positive, since we assume that C sub x is going to the left, so therefore, with respect to point A, C sub x creates a clockwise moment at A. So that is negative C sub x, and its perpendicular distance from A is 3 plus 2 feet. So that's 5 feet. 5. And then we have 300 as well. Creates a clockwise moment about A and has a perpendicular distance of 3 feet. So that's minus 300 times 3. Next. Okay. Next, uh, the x component of 600 pounds will not be considered because its line of action passes through point A. So only E sub y, and E sub y is 600 sine 60, and its perpendicular distance is 4 feet. So that is minus 400, minus 600 sine 60 degrees, parentheses, times 4. And then our 750 pounds is also, uh, what do you call that? Clockwise moment, couple moment. So that is minus 750. Minus 750 is equal to 0. Since we are only concerned with C sub x, so we transfer the rest to the right-hand side of the equation. So this becomes negative C sub x times 5 is equal to positive 300 times 3 plus 600 sine 60 degrees times 4, and then plus 750. So then we divide both sides by negative 5. C sub x, C sub x is equal to 300 times 3 plus 600 sine 60 degrees times 4 plus 750 divided by negative 5. So our C sub x is equal to that's 300 times 3, that's 900 plus parentheses 600 sine 60. Wait, two open parentheses, 600 sine 60, close parentheses, times 4, and close parentheses. That's 2,978.460969 plus 750. That's 3,728.460969 divided by 5, and that is C sub x is 700, oh, it's negative, where is my cursor? Negative 745.692193. 21938 pounds, since we ended up with a negative answer. So therefore, C sub x is 745.692193.8 pounds. It's either you provide arrow to the right, to the left, or you write the word to the left. So this is our C sub x. Okay, and knowing that, we can now calculate for our A sub x, which is we do force summation in the x is equal to 0, assuming all forces to the right is positive. So that is, if you can observe, we have 300, we have x component of our 600, and our C sub x, which is to the left. So this is A sub x plus 300 plus 600 cosine 60 degrees minus 745.692138 is equal to 0. So A sub x is equal to positive 745.692138 minus 300 minus 600 cosine 60 degrees. So if this is equal to our A sub x is 600 cosine 60, that's 300 plus another 300, that is 600, 745.692138 minus answer, that is 145.692138 pounds. Since this is a positive value, so it means to the right. So this is now our the support reaction at A. Since we are tasked to find the component, so we don't have to express it as a single force. And then the force exerted on the arm by the link at C. So this is example 14.